Hi, I hope you are all having a good day. In this video, we would like to discuss on the topic inter-process communication. Whenever you try to exchange data between one process and the other, which may be in the same network or which may be in a different connection, which can be between one or more computers or one or more programs as such, then we are supposed to talk about the synchronized execution, and therefore the inter-process communication include variety of mechanisms. One is process tracing, the second one is sockets, the message passing, and the shared memory concept. In this video, we would like to concentrate on how a socket is going to work. Now, when there is an inter-process communication, it's similar to a mail program which tries to contact some other remote machine based on their email login, and then you have a mail agent for that particular system. When you log in, you try to get those information. Now, normally in a Unix system, you have to have communication between data and control portions very frequently, and the control portion may contain the addressing information. Different formats will be followed, and these addressing information and the formats vary between network to network. And if at all we follow the protocol of the normal protocol, I should know the addressing format of which system I am going to communicate with, or this process is going to communicate with. But that is not recommended in a Unix system, because Unix system feels that you have to communicate as if you don't know about the process or the steps which are being handled behind the screen. And therefore Unix is wants users to be unaware of the file type, devices, the network, or the system what we are going to communicate with. And then this is the reason why we have come up with very many standards, and one among them is sockets. Now, to provide and sockets, you allow some sophisticated protocols. We inherit these sockets from the BSD system. This allows communication between host or between any one process to the other over the internet or in the computer. Now, the kernel structure of the socket will have three layers: the socket layer, protocol layer, and the device layer. Now, the socket layer acts as an interface between the system call and the lower layers. The protocol layer tries to format the information in the required address formats so that the complete addressing part is taken care of, and the device layer tries to communicate with the device drivers so that the communication is very smooth. So we have a server as well as a client process. Now it's similar to an phone communication what we normally make. On to the caller, so the person who calls has to have a phone. You have a phone number which has been assigned, and similar thing goes with the receiver on the other part. Now what happens, you try to lift on the phone and dial a number on the caller side, whereas on the receiver side he listens for a tone and he tries to receive it. Once on the receiver side there is a ringtone, we pick up and we try to call. When we pick up, there is a connection which has been made, and that connection you are supposed to say from the caller side that this is the number to which I am going to connect. So you have a connection which has been made, and then we try to communicate the data which moves in terms of signals. And once the communication is over, both the sides you end of the call. Same thing happens when it moves on within socket programming. The socket programming consists of a server as well as a client. So the end-to-end communication is either set up by a server or the client using a socket system call. And then once the socket system call tries to set up a communication, we have to assign an address to the endpoint. That is done by using the bind system call. Now this is important for the server side, where it is optional for the client side. Once you have assigned an address, then we listen from the client to pick up or attend to the call or to respond to the call, or in network terms we acknowledge to the call. So you have a listen system call, and they try to attend, you try to connect the client and the server with a connect system call. Once that is done, we accept it, we are given acknowledge, and then you have a send receive, both the sides from server to client. You can send the information as well as you can receive the information, and vice versa. And at the end we try to close the conversation. Now these are slides which tells you about what is the format of different system calls and how it works on. So the socket system call, as I said, is used by both the server and the client to establish an endpoint communication. We talk about what is the communication domain, whether it is an internet domain or an Unix domain, and that is represented in the format parameter of the socket. Then the virtual circuit or a datagram packet is being sent, is being decided, the type of communication is decided by the type, and whether it is a TCP IP or an UDP protocol, that protocol definition is given here. So we have the format, the type and the protocol, and SD is a socket descriptor which will be used in other commands so that you can use the socket for communication. Now bind, as I said, it assigns some address. So we use the socket descriptor what we retrieved in the socket command, and then that acts as a parameter. The address or the pointer points to the structure of the specific communication domain, as well as the length of the address structure is also described here. And then we try to listen. We listen through a socket, through a connection. So for that connection we use the socket descriptor and also the queue length, that is the number of requests what has been outstanding. And then we connect it. Connecting again goes with the address of the socket, target socket, the socket descriptor through which we are initiating, and the length of the address structure. On the other hand, we accept it, and then if I want to send a new system call, you have a new socket descriptor which comes into picture, and then we accept, while you accept the old socket descriptor and the address length, now we have handshake between the client and the server, and we have accepted the request, and therefore we have the new socket descriptor. We know what type of addressing we are going to follow, and we also know what is the address length which is initiated. Then we try to communicate. Either you send or you receive the data. When you send, you can count the number of information what you have sent, number in bytes, and that has the socket descriptor, the message length of the message with length, and then you have a flag, the message what you are going to send, and the flag. Now this flag will be out of band, can be set to out of band, provided they are not a part of the regular communication, and this will retrieve the total number of bytes we have sent. Similarly with the receive system call, it takes in the buffer, it defines a buffer where all this data can go and be stored, the length of the expected length of the message, as well as the flag. Flag tries to examine, flag when is set to peak, it tries to examine whether examine the message without removing it from the queue. Once it is in the queue itself, it tries to examine and find out the content, whether it has to be forwarded to someone, or it is the message which is been received by the client for further processing. And if you have to close the socket, you go on with the shutdown mode, you finish off the communication, you close it down, and to get the socket name which we have already developed, then you say you get socket name. To get the older socket which we have already defined, and I can bind it through a set socket option. So these are the calls what we can use, these are the system calls what we can use to communicate between an server and the client. Thank you.